So in this class, we'll be learning two types of database management skills, right? Relational database and dimensional database. Do you still remember that? Okay, very good. Relational DBM. I will use DBM to represent database management. Right? What is another name for relational database management? OLTP, right? OLTP.
Yeah.
Yes, very good. And another name for dimensional?
OLAP.
OLAP. The reason we call relational database OLTP because the purpose of a relational database is to record transactions. So basically in the future, if your boss or your colleagues ask you to develop a database to record transactions, to record the customer signups, orders, right? Customer service records, all of this transaction information can be recorded by relational database. OLTP stands for online transactional processing. So this basically explains the purpose of a relational database. And OLAP represents online analytical processing. So basically, this explains the purpose of a dimensional database management. It's for analytical purposes. Yeah. In relational DBM, we will learn two important concepts. What is it? Normalization. Very good. Normalization. So later in this class, we'll also talk about normalizations in detail. We have different types of normalizations. Yeah. And along with normalization, we have a primary key, foreign key. They are connected. Primary key, foreign key. Okay. Foreign key. This is what we will be learning in relational DBM class. And then dimensional DBM, we actually don't encourage you to use normalization. We encourage you to use denormalization. We encourage. Encourage means you can use normalization, but we just don't encourage that. We encourage you to use denormalization. I will give you an example. We encourage denormalization. So what is denormalization? It's the opposite operation of a normalization, right? Yeah. Yes. What is normalization, by the way? It is a process of transforming poorly structured database into well-structured database. Let's see an example. So we will be talking about the denormalization and the dimensional database in more details later in this semester, but I want you to remember the key feature between the two types of databases. In relational database, we use normalization for sure. Our goal is to identify the most fundamental, most atomic components in your business process, and then create a special table for each component. For example, if you want to record who ordered what, you have to create 3 tables. Who represents the customers table. All the information about the customers will be recorded in customers table. What represent products. All the information related to products will go to products table. Order represents another component in this business process, right? In order, we have to create a order ID and record the customer ID, product ID, and the quantity the customer ordered. Yeah. We have to find the most fundamental, most atomic. Atomic means it's like the component, it's like the chemical components, right? A drop of water consists of H and O. We need to identify what is H, what is O in our business process. This is the goal of relational database. And you remember, this process, when we identify the most fundamental component, this process is called a normalization, right? We cannot record everything in one table. We have to normalize the database. Denormalization means we don't care about the most fundamental, most atomic components. We basically record everything together in one table. Let me show you why. Let's take a look at the example. So we want to create a database to record who ordered what, right? This is the purpose of OLTP, or relational database. Currently, we have this design. We said this is correct because we get everything recorded. We get our job done, but this is not efficient. Why? Because think about Amazon. Amazon has millions of orders happening in every second. If you record the data like this design, you have a lot of redundant data. For example, you will keep recording customer's name, address over and over again if the customer places several or multiple orders, right? So this design, obviously, this relational database design is not efficient. It's correct, but it's not efficient. That's why we have to think about a way. We have to normalize this database and split data records into different tables. That's why we record a table like this, record transaction like this, right? We record all relevant information about the customer into the customer's table, all relevant information about the orders into orders table. But we are not satisfied. Why? Because we can further normalize this design into this design. Okay. Now, when we record the transactions, it will be more efficient because customers' information is barely changed, right? If you have your first name, you barely change your first name. And you just give a unique ID to the customer to identify him or her. If he places an order, in the orders table, in the current table you see, in the orders table, you just record the customer ID. Same thing for products, right? All relevant information goes to products. So this is the key feature of a relational database. We want to normalize the database. We want to find the most fundamental, most atomic component in your business process, create a table, particular table for each one of the components in the business. How can we connect these three tables? We use keys, right? We use primary key and foreign key. Keys are basically IDs. A primary key is an ID that can help you identify one unique record in a table. For example, customer ID. As long as you type in one, you will find Bohan from Commerce, Texas. You will not find another person. Then customer ID in the customer table will be a primary key. And then, as I said, we use this primary key in the orders table. If the customer places an order, customer number one places an order, we record ID number one in the orders table. That's why you see multiple ones in customer ID. When you type in an ID number one in the orders table, can you find just one unique order? You can't. Why? Because, yeah, a customer can place multiple orders. But if you bring customer ID number one, if you bring this, no matter how many ones you have in the orders table, you bring this once back to customer's table, how many unique customer can you find? Just one. We call this type of keys foreign keys. Foreign keys. Foreign keys is a unique ID. It's an ID that can help you identify a unique record, not in the current table, but in another table. Yes. The whole purpose of normalizing data tables is to record transactions more efficiently. This is the whole purpose. Think about Amazon. It is much easier to record IDs in the orders table than your previous design, right? If you design like this, you have to keep recording the known information over and over again. It's not efficient. It's correct, but it's not efficient. As a professional database manager, you want to make your database very efficient. That's the purpose of a relational DBM or normalization. Okay, now we talk about denormalization. We'll talk about the denormalization in more details later in this semester. But in denormalization, we do not normalize table. We do not split table. Why? Don't forget, another name of denormalization is dimensional table is OLAP. It's for analytical purpose. Your goal is to analyze the existing data records. It's not recording transactions. So it doesn't matter how many redundant data you have in the same table. As long as you can analyze, that will be good. Okay? That's why in denormalization, we encourage, in dimensional database, we encourage denormalization. You get the point? Very good. Very good.